Hey, I hope you all had a great Thanksgiving. This is a quick lesson to wrap up section 3-4 for us and to ease us back into school. So we were almost done with section 3-4, talking about second derivatives and concavity, but we did not get to this idea of a second derivative test. So the second derivative test says that first thing we need to do is take the first derivative, set it equal to 0, and find those possible critical numbers. And then the test says that you plug those critical numbers into the second derivative. And if that answer is greater than 0, then you have a relative minimum. And if that answer is less than 0, then you have a relative maximum at that point. But if it equals 0, then the test fails, and you have to do the relative min or the relative max using the first derivative test. So I'm not a huge fan of the second derivative test just because we already have a way to find relative mins or relative maxes by using the first derivative test, but we can do it. Example 4 says find the relative extrema of f of x equals negative 3x to the 5th plus 5x to the 3rd by using the second derivative test. Alright, so we need to take the first derivative. And the second derivative test says we have to find this value where the derivative is equal to 0. And we will always try to do that by factoring out the GCF. I factored out a negative. Set your factors equal to 0. Divide by 15. Take the square root. Set this factor equal to 0. Add 1. Take the square root. So we have 3 c values to test in the second derivative. So the next thing we need to do is do the second derivative, or find it. And then we're going to test each of these values. This second derivative test is going to tell us if we have a relative min or a relative max at these points. So if you plug a 0 into the second derivative, you get 0, and the test fails for this value. You plug the positive 1 in to the second derivative, and you get a negative, which means that 1 f of 1 is a relative max. And then when you plug your negative 1 in to the second derivative, you get a positive 60 and a positive 30. You get a positive. So the point negative 1, f of negative 1, since it's positive, is a relative min. And that's basically what the second derivative test tells you. And we would have found that the same way in section 2. We took our critical numbers, put them on the number line, found the intervals, and then we tested numbers from each of these intervals into the first derivative. And if it was, let's see, oh, I've already erased my first derivative. Let's see. I have it written down though. It was negative 15x to the fourth plus 15x to the second. I might have done my second derivative wrong. Can't go back and check, but my exponent here may be wrong. But everything else is correct as far as this giving us a relative max and this giving us a relative min. But I might have missed that exponent. I'm just now seeing that. So when we test these numbers in the first derivative, negative 2, testing here in the first derivative, would give us a larger negative. So this would be negative, so it would be decreasing. Negative a half would give us a larger positive. So this would be positive, so we would be increasing. Positive a half would also give a positive, so increasing again. And positive 2 would give us that larger negative, so we'd be decreasing again. So that would mean, according to the old way we had of doing this, if we had a relative min here at negative 1, which agrees with what we got with the second derivative test, and right here we'd have a relative max at x equals positive 1, which agrees with what we have here. And remember how that test failed at 0? Well, 0 was right here, and it wasn't a min or a max. It was positive, positive. It was just increasing through there. So it all agrees. All right, that's all I've got for you all. I'm going to ask you to turn to page 192. And we're going to do the second derivative test with number 31 and 33. Alrighty, I'll see you all Wednesday.